looks like it is a success story with happy end, right? The truth is not. So the whole story is about permanent pain. It's a permanent and infinite pain, right? Behind the scene, what happens is that these guys and the rest of the team, we are trying to hide all the complexity and all the troubles and pain from you guys. I have a question, by the way, because Gleb mentioned Cilium, KubeVirt, and how many of you are familiar with this stuff? Some of you, but not all of you, right? Because they're kind of complex. I do not say they are like crazy complex, but many of us, back to my point, why I spent your time in the very beginning talking about user experience and all the things. So we are trying to hide complexity as well. I counted the number of simple words mentioned by Gleb. He mentioned it only once when he mentioned simple underlying network. What do you think? How simple is the underlying network? It's not simple at all. So our goal is to hide complexity from you. And of course, our goal is for you who just don't really like to invest your time and care about, all the things behind the scene, just start using it. So when we are talking about HPC, it's in some perspective, HPC is a kind of flavor and the old verb which was used for, data, ML stuff and stuff like this. Actually, Slurm is quite popular there. And the idea was, when we start delivering our cloud, is how to simplify the way how the guys busy with HPC and ML, how to help them to start using our cloud. That is why our next session is about how we manage and how we marry Slurm with Kubernetes. So welcome, Kirill. And yeah, he will deliver you just another exciting story.
So is this on? Yeah, can you hear me? Great. So my name is Cyril, and I'm solution architect in Nebius. And well, basically my job is to help our clients to deploy, scale, and troubleshoot their machine learning workloads. And today I'm going to tell you about Soperator. So maybe let's start with a quick tour of the audience. So how many of you use Kubernetes? Raise your hands. Yes. And how many of you use Slurm? Quite a few. So basically, as you can imagine, like the intersection between these two audiences is not very big. So here we are going to basically tell you about what both of them are and what it takes to marry Slurm with Kubernetes. So let's start maybe with a quick introduction of each of these tools. So Kubernetes, as many of you know, is a container orchestration utility, which, it uses control and workload nodes. It uses a declarative approach where you decide the state of your application in a YAML file. It is highly scalable and self-healing. It will try to maintain the state of your application which you define. And it also features high availability, like you can distribute your workload on multiple nodes, you can have like redundancy, replicas, like whatever you want. And it also hides all the networking complexity away from you. It manages networking really well on its side. And about Slurm, basically, well, it's an HPC workload scheduler. Yeah, like Kubernetes, it has control and worker nodes. And contrary to Kubernetes, it uses an imperative approach, well, where you don't, you just write down the procedure which you want to run in a bash script, and like you use some special comments as like metadata to define the resources you want to use, and yeah, all this stuff. It's really good at fine-grained resource control. Like you can basically define up to like which CPU core on which NUMA node you want to use for your workload. And it uses a queue-based execution, so when you submit your job, it gets placed into the queue. And yeah, it has some utilities to to ensure fair, like the compute resources are used in a fair way. So it's really made in mind to be used by a team of like ML practitioners or researchers. So there are these things in common, like, yeah, they both allow us to manage resources. They're both scalable. We can have like dozens, like from dozens to thousands of nodes if we wish so. And they both provide us some level of automation to facilitate our job. But at the same time, we shouldn't forget that these are two like really different sort of tools. Because, well, first of all, they were built in a different time. And they had like a different pattern of usage in mind and different, like, and they cater to different audiences at the same time. So let's probably go through the Slurm setup. And so here you have like the basic user experience in Slurm if you never used it before. So basically you connect to like your login node, like over SSH, like to any Linux VM. And you have some commands in your user field, like to interact with the Slurm API. So you can like submit your jobs, list the queue, delete it, like get all the information about the nodes, like drain them, undrain them if you want. So basically the way it works is that you issue commands to your Slurm controller, and then it will interact with the nodes like using RPC via TCP/IP. And another optional component is the database, where you can keep your information like on your jobs, for example, like how long did it take, why did it fail, if it failed, and etc. And, well, does it have drawbacks? Well, yeah. By the way this question is formulated, you can imagine it has. So, like, first problem is that sometimes we have to manage multiple environments. Like, depending on the hardware you use, it can induce software differences and just make it like relatively difficult for you to manage. And the second problem, which we often have, is with scaling, because obviously, if it's like you will want to scale your cluster up and down depending on how much compute do you need. And the next problem is managing like a large number of hosts. Like every worker node has to be like prepared, bootstrapped. You need to make sure it's like has up-to-date drivers and it can be monitored in an efficient way. And also you need to have some way to maintain the stability like of this working environment. So how do we usually solve these problems when we deploy Slurm clusters? So usually the answer to everything is Ansible. Oh, it's a really powerful tool when you want to deploy your bespoke configuration, like of your with the certain libraries and like versions of the software running on your nodes. But it doesn't really help us with other issues like managing and like scaling, like to a lesser state. And like from what you have already noticed, like the problems to which I put some attention here is that most of them can be addressed by Kubernetes. And yeah, like as you have noticed in our company, Kubernetes is basically the answer to everything. And it's really good. But the issue is, like, there's always an issue, is that by the time when we wanted to get our solution out, there was no off-the-shelf utility like to run Slurm on Kubernetes. So this prompted us to develop our own solution to run Slurm on Kubernetes, and here I'm happy finally to present you Soperator. So Soperator basically it's something which enables us to run Slurm on top of Kubernetes. So by itself, it is presented in a form of a Kubernetes operator. So for those who don't know, Kubernetes operator is basically like imagine if you have some complex application like Slurm, and you have like a lot of moving parts in it, and you need to ensure that they interact with each other in a certain way, and it also respects a very structured procedure when we deploy this application. So for this, what we can do, we can create like what we call a custom resource in Kubernetes, and that's essentially what we did with Slurm cluster. And basically, the operator, it will just, well, it's just a pod which will monitor the state of this resource and will bring it to the desired state, like which we define at the deployment. We wanted to give you, the users, the most straightforward way of like using Slurm, like not to drift too far from like what you probably used to, like when you use it like in other vendors or like in academia. But we also added some quality of life features, which we think are really, really nice. So first of all is that we have a shared root file system. So basically, like I'll go a little bit into details later about it. Yeah, we implemented hardware health checks because, well, as you know, GPUs can be a bit finicky and like can fail sometimes. And yeah, we implemented some ways to keep them in check and make sure that users always have a good hand on what compute is actually available for them and usable right now. And it's also very easy to scale. But basically, you just change the number of like your worker nodes in the resource definition, and yeah, you have this many workers if you want. And like the next features, yeah, they're probably more related to the fact that it runs on Kubernetes now. That yeah, it can be self-healing and have high availability, and it's a little bit more difficult for user to break stuff because as it's a Kubernetes resource, even if you do any changes, like operator will bring it back to its state. And it's easy to deploy because like before we used, like I mentioned before, we used Ansible to deploy Slurm for our clients, and yeah, it wasn't that straightforward, and especially scaling it. But like right now, it's like really easy to deploy. Like it's just like we have some Terraform recipes for it, and it's like end-to-end, like provisioning the Kubernetes cluster and installing Slurm on it can be done like in 30 to 40 minutes. It also integrates really well with observability stack, like which you all probably used to in Kubernetes, like Prometheus and Grafana. And like you shouldn't forget that underneath you still have the Kubernetes cluster. So if you want to like reuse your compute for something else, maybe run inference on the same cluster, you can do it. Yeah, let's continue and see how actually the Slurm resource itself like is represented in Kubernetes. So every component of Slurm, like controller nodes, login nodes, or worker nodes, they're basically pods, and they're like represented by the corresponding service in Kubernetes. And the shared file system, which I mentioned before, it's from Kubernetes point of view, it's just basically a persistent volume with a read-write many access mode. And the way it is presented to user is, well, I can say, yeah, it's in a bit clever way because you would imagine that you have the pod which runs the Slurm, which represents the Slurm node. It has its own root file system, and we have this shared file system just mounted to it. And at the moment when we connect via SSH or we launch the workload, when the process which will run the job is launched, we use chroot just to change, like, yeah, to go into the jail file system. Yeah, yeah. By the way, it's called jail. It's an homage to BSD jail. Yeah. So yeah, this file system is shared, but it's not like entirely shared. Like as you can imagine, not everything can and should be shared. So like the things which are like node specific, obviously drivers and devices, like you can share them. And there are also some other parts which you would want to keep like on the node, like cache and temporary directory, and also container file system if you like use Slurm to run containers. But like all the rest of the root file system is shared. So like if you have like any of your data, you have more importantly like binaries and users. This will all be shared. This will all be like if you like do something on one node, it will be all propagated to like all the rest of the nodes in the cluster. So yeah, this is just like an illustration that from a user point of view, they will connect to the login node and they can like do like basically anything like they would do like on a Linux VM. They can install new packages, they can create users, and this will all be shared immediately by all other nodes. And obviously, if your job produces outputs, like you do like batch inference or like checkpointing, it will be all stored on the shared file system as well. So about our hardware health checks. So as I mentioned that we run some health checks to sort of weed out like unhealthy GPU nodes. So basically what we do, we just run a nickel test. And the way it works is that we have a Kubernetes cron job, which creates a Slurm job, which in turn will run the nickel test and compare the output, the value of the bandwidth with the reference. And if the node doesn't reach this value, it will be drained and become unschedulable for the users. So yeah, here how it looks once this check fails. And yeah, so this concludes the explanation of how Soperator works. And this basically allows us to sort of profit from like both worlds, the Slurm and the Kubernetes, and it makes it really easy to scale. So like in this sort of illustration, here you have this layered cake. Like on the very bottom, you have your like compute. It's either VMs or bare metal. On top of it, you have Kubernetes, and again, on top of Kubernetes, you have Slurm. So basically, to scale Slurm in this case, you just scale first your Kubernetes cluster, and after that, scaling your Slurm cluster is as easy as just changing a single value in the resource definition in the Slurm cluster CRD. Okay, so this is all very nice, and also important thing is that Soperator runs a monitoring stack, so we have Prometheus, Grafana, like Victoria, metrics. Like all of these things, I guess, are very familiar for you if you're used to run Kubernetes, but yeah, it's very important nonetheless for people who are used to Slurm. And just to summarize that, yeah, we made our solution from which allows us to run Slurm on Kubernetes. And yeah, sorry, the really important thing is that it's developed by our team in-house, and basically it really sets us apart from other vendors who would be offering Slurm running on their compute, because like imagine if you're running your workload and you have any bug, there's a good chance it will be fixed this evening. Or if you like want to get like a new feature which requires some development, there's a good chance you'll get it next week. For example, like we have a customer who wanted to use like a custom container runtime like Singularity, and yeah, we released the new revision for them next week. So yeah, that's really strong thing, I would say, that having your like your own managed solution, which is supported by your own development team. And yeah, at this moment it still has some limitations. I would say that right now that all the Slurm nodes, like worker nodes, they have to be the same. Like they have to use the same flavor of the GPU, but we are working on implementing like different node set features. And obviously, like as you can imagine, some like critical software versions, they have to be pinned. Like users, they can't really modify which like distro they use, which Slurm version, or which like NVIDIA drivers they will be using. Like this is managed by us at the moment, but at the same time, as I mentioned, if you require some specific version, it's really easy to get. And well, in the future, what we plan to do is, to make it more secure, to introduce like some other features like on-demand nodes for like to make it more interesting and more easy for like from like monetary point of view to scale up and down your Slurm cluster. Also introduce topology-aware job scheduling, because as I mentioned, Slurm, as a contrary to Kubernetes, allows you to do like a really fine-grained resource control, and you can also benefit from like knowing the physical topology of your GPU nodes in the infinite band fabric. To also improve our self-healing capability, and to introduce additional hardware checks. And the most interesting thing about all of this is that you can help us with this, because this is entirely open source, and you can submit your PR, and we will be happy to get it from you. So thank you guys, and I will be happy to answer any questions about it.
Yeah. So please, if you have any questions, please shake your hand, and a microphone will be delivered. While we are waiting and you are thinking about the questions, actually, of course, we are hiring. And so we are looking for the guys like Cyril, and you can see the scale of his intelligence and mine, right? So guys, we are hiring solution architects, developers, so please let us know if you're thinking about the new opportunities. Anyway, any questions? Please shake your hand. Okay, there's one. Yes, please.
So, really weird thing to talk into. That's pretty cool. Well, we obviously met Cyril, so you know me. I'm actually interested, like you working on the side more of the like practical AI and implementations. And I know that you started like working with Slurm as a job scheduler quite recently for your career, at least. Why do you think like we have a pretty like substantial amount of like AI labs running Slurm? Why do you think it is so popular on our platform? What makes Slurm that good that we decided actually to implement it over Kubernetes as a standalone managed solution?
Well, I think there are two parts to this answer. First of it, I think, is that a lot of people coming into like startups, for example, like having some background in ML research and in academia, well, they just used Slurm before, and it's like because it's pretty popular in academia, like like as your HPC workload manager. This is like one thing, and the second is that I think a lot of people are intimidated by Kubernetes, and well, you shouldn't be really. It's just you just carve yourself like a really small part of the cake, which is Kubernetes, and like you can use it like pretty efficiently. And it's probably more user-friendly for beginners in this way.
Yeah. Any other questions? Okay. So just one more. Yes, please. Okay. And so while we are waiting, just to remind you, actually, Cyril, he's one of our solution architects, and yes, Slurm and Soperator with Kubernetes, Soperator as a solution, is a simple thing. But actually, when we propose you to go through the POC, proof of concept or pilot project, or we start in production, actually the team of our solution architects help you even configuring this stuff. So we are making simple things even simpler. Yes, please, your question.
Hi, I was wondering why you decided to make Soperator open source in a market that's very competitive right now with all different kinds of providers. Why not try to make it a differentiator for Nebius?
I guess it was just because, well, Slurm itself is open source, and it's also just because we just identified this sort of niche, which could be which could be useful for the community, you know, and like as you know today, like I think there's like another thing which exists, like Slinky, for example. It's like another sort of solution based on Kubernetes, but like at the moment when we decided to develop this, it wasn't released yet, and so yeah, I guess, and it's also, well, in a way that like if you have a solution which doesn't exist yet and you're like the first, you can sort of maybe try to attempt to steer the market like into a certain like way of using like this solution, and at the same time if it works well, you can benefit from from the community, because well, Slurm is like very popular in research community, for example, and like open source community and like academic research, they're like very heavily intersected with each other. Like, this is also another thing. And yeah, I forgot what I wanted to say. Yeah, I guess that these are probably the main reasons. Yeah.
Of course, our goal is to stay big and be even bigger in perspective of market share. And a lot of things we are making, actually, we make them either we base them on open source, which were developed in, if you remember the first session, at the Yandex, the company, like the company which made the foundation for us. So they open sourced a lot of the things they developed, and we just continue this great tradition. And also it helps to keep us good market share. So our major, let's say, milk cow, the thing we earn money is, GPU stuff, and some other things we are going to talk today. Any other questions? Yes, please.
Yeah, hi. Great presentation. Just one question. Most of the customers are mainly interested in performance. So they might have experienced native Slurm and the performance on it. Are we also providing the similar performance with Soperator as well? Like, have we done some benchmarking?
When you mean performance, you mean the compute, right?
Compute performance.
Yeah, well,
we will get from, let's say, running a training workload on top of it.
Yeah, well, basically there is no performance penalty because like especially like in our cloud, before we developed Soperator, we provided Slurm on virtual machines, and like there is no difference in like installing it on a virtual machine or on a Kubernetes node from this point of view. And as Gleb earlier, he managed, like, for example, like critical compute, like critical resources like GPUs. They're not virtualized, like it's a pass-through, so there's no penalty. Basically, like the aim was to develop something which retains the similar or better user experience for Slurm users and makes it simple for people who manage the infrastructure, like DevOps engineers, to manage it.
So, sorry, one more question. Within Slurm, we have PyXis support as well, and root and PyXis support to run a container. Is Soperator also provides that?
Yes, sure. Sure, yeah, we use it extensively, like in our tests, for example. Because, yeah, I mean, Slurm by itself, it has maybe a little bit different logic. Like maybe it came like before like the containerization became like really popular. You tend to install everything like in your environment, or like have modules or something like that. But well, from my personal point of view, like containers like are the proper way of running your workloads on Slurm, and of course, yeah, it supports it.
Sounds good. That's it.
Okay. Thank you. And you know what? So thank you for asking questions. I have a gift for you guys who ask the questions. Please reach us, and we have some T-shirts. Not me, but Melissa on the backstage. So guys, the best time of the day, right? Break. And I hope to see you in 15 minutes back. Thank you very much. Let's get some snacks and drinks.